Let's begin the lesson for the multiple state tags. Click Add. Select Multi-Status. The dialog box will change like this. Let's type in. For the name, type in multi-0001, and for the address, 40,011. We are using the 10th address of the analog output as the multiple state tag. Let's change the status names. Type in OFF1 and ON1. Now click the Expand tab. Enable output and the rest of the features are already explained in the previous lessons. The multiple state tag uses multiple status. Right now we are using for, off, on, OFF1, ON1. Data is set to use 4 bits. Now let's try to control using the multiple state tag. Go on View. Select View Tag Values. Let's control the tag. Set it to off. Alarm system works when using multiple states. Check Confirm Control to prevent the alarm. Let's look at the PLC memory. Open Memory Map. Move down to 40,000 S. Now change the tag to on. Let's see which memory has changed. Memory 310 has changed. Since the address starts from 40,001, memory 310 would be 40,011. The memory of the address has been controlled to 1. Let's change it to a different status. OFF1 will control it as 2. ON1 will control it as 3. So, you can monitor and control the values using one tag. Set how it controls the input value and output value when the status changes. When the input value is 0, it will display 0. When it is 1, then 1, if 2, then 2, if 3, then 3. So, if input value is 0, then it will display as off. When it is 1, then as on. Let's change the input values to 1, 2, 4, and 8. When the first bit changes to 1, then it will display off. When the second bit changes to 1, it will display on. And when the third bit changes to 1, it will display OFF1. So this will work when the input values are 1, 2, 4, and 8. Set the output values as the real value when it is controlled off. Type in 1, 2, 4 and 8. Let's see how it works. When it is off, the first status displays off and the output value as 1. When it is on, the output value is 2. OFF1 will display 4 and the third bit will change to 1. ON1 will display 8 and the fourth bit will change to 1. Last, the number of bits. When the number of bits is set to 4, it only uses 4 bits. It does not use the entire memory. Rather, it uses only the last 4 bits and ignores the values in the rest of the bits. Now go on to Designer. Next, the string tag. Click Add, and type in SRView04 Type in test as the string value. This is simple, so it only has one tab. Rests have been explained previously. Run view. It is not easy to show how it works on view tag value. On the test screen created earlier, insert the tag value on the bottom. Select string tag. Let's make it bigger. It is used to make a memo by the users. Let's type in, pump 1 check required. It is commonly used by the operators who do shift work. Next, the accumulation tags. Type in ACC0001. Under the retentive tag, there is an item for the input tag. The accumulated values from the field normally have small memory, so when it goes over a certain value it will reset to 0. So, it keeps on obtaining accumulated values even after it resets to 0. Also, it is used to display the accumulated values divided into hours, days, months, and years. Select a tag. Select AI0001 as an input tag. When AI0001 has set a device that increases the value of flowmeter and watt-hour meter simultaneously, select accumulation to get the accumulated value. When you select accumulation as data type, it displays the value accumulated since the program has been installed. Let's look at types of data. You can select data from current hour, current day, current month, current year, previous hour, previous day, previous month, previous year, current time range or previous time range. There are 5 types of data each for the current section and previous section you can select from. Let's examine the current hour value. As I mentioned before, normally, it recalculates to keep on obtaining accumulated values even after it resets to 0. Let's look at this PowerPoint on the field. Numbers on flowmeter and watt-hour meter increase. When there is no flowing or use of electricity, the value does not change, then increases when it begins to operate. Based on the current hour value, the value will keep increasing until the start of next hour when it will reset to 0. Then, the value will increase again. So, the value that resets every hour is the current hour value. Then what is the previous hour value? The value just before the current hour value resets to 0 every hour will be recorded as previous hour value, and then the current hour value will reset to 0. The value accumulated in the previous hour is the previous hour value. So, for day, it is the accumulated value before it resets every day; for month, the value before it resets every month; and for year, the value before it resets every year. For the time of your choice, select the time you want to set. If you select 10 minutes, it will let you use the value every 10 minutes. Select analog as the type. When the tag set in input tag is not an accumulated value but a general analog value such as water level, it is used to calculate the flow rate using the algorithm. Set the type to running time. The running time is based on the value set as the run value. So if the run value is 1, it adds the running time when it turns to 1. Then the running time stops when it becomes 0. When it is back to 1 again, it adds the running time and gets the result. Next, is the counter. when the run value is 1. It adds 1 every time the value of the input tag turns 1. For the counter, it adds 1 whenever the value changes to 1. Factor is the value that multiplies with the accumulated value. Now, on cut value and reset value. The cut value works the opposite depending on whether the type is accumulation or analog. When it is set to accumulate, it compares the current value to the previous value, and it ignores it when the value is greater than the cut value. When the cut value is set to 0, it works with any value. For the reset value, type in the limit value for the increasing accumulated value to reset to 0. So when the value resets to 0 before hitting the reset value, it recalculates the value as the accumulated value. We recommend you to set the value according to the capability of the machine, even if you do not know which value to put in. It will still work with the initial value since the value changes every time it resets. When the type is set to analog, and, for example, if the input tag is water level, it will not receive the value as exactly 0 even if there is no water. For instance, it will move back and forth between 0.1 and 0. In this case, in order to prevent accumulating unnecessary values, input cut value to ignore values smaller than the cut value. Next, the calculation tag. Select the calculation tag, and type in CALC0001. Type in the formula here. On the right button, you can type in the formula with the tags. Let's add 3 tags. Type in the formula and select tags. This is to make Calc 0001 by adding those 3 tag values. Rest have been explained previously. This was all for the tags. Now moving on to virtual tag. Click Add. You can select virtual tag for digital, analog, and multi-state tags when you select the virtual tag. You will not be able to type in the address. Type in VDI0001, and leave the rest as it is. Click OK and a virtual tag without input or output address will be generated. This tag allows you to control and see the values using computer memory regardless of PLC. Think of it as a tag internally used in SRView. Also, you can create an internal tag to monitor and control by selecting analog and typing in VAI0001, or selecting multi-state tag and typing in VMULTI0001. This was all for the tags in TagEditor.